Hi, welcome back. Let's take a look at this electricity question. Question number 6, a battery with an EMF of 18 volts is connected to 4 resistors as shown. Okay, we've got the diagram. Okay, 180 coulombs of charge passes through the 2 ohm resistor in 1.5 minutes. We'll skip the definition for current and go to question 6.2. Calculate the reading on ammeter A2. So question 6.2, the ammeter reading. So they tell us that 180 coulombs passes through the 2 ohm resistor. So this is our 2 ohm resistor right here. Okay, and they want to know A2. So A2 is connected next to the 2 ohm resistor, so we can use the information that we were given from here. Now we can use the formula I is equal to Q divided by T. They tell us that it's 180 coulombs, so 180 divided by time. Remember, time needs to be in seconds. And so 1.5 minutes is 90 seconds. So 180 divided by 90, that's equal to 2 amperes. Question 6.3, well, 6.3.1. Determine the effective resistance of the parallel combination. Okay. Now, where is the parallel combination? Let's go and highlight this. So I'm going to start with my battery. So this is where all the current is going through, and then it reaches a point right here. Now at that point, it's going to split. It's going to go through the green path, which we've already highlighted, and it'll go through this brownish path here. It's then going to join up back again, and going to go all the way back right through to the battery. No current will pass through right here because that's a voltmeter, right? Current does not go through voltmeters because voltmeters have an extremely high resistance. Okay, so they want to know the effective resistance of the parallel combination. So they want to know what is the resistance of the green and the orange path together. Okay, so first thing we're going to do is we're going to see that in this green path, we have these 2 resistors that are connected next to each other. And so we can add them because they are technically in series. So 2 plus 1 is 3. So we have a 3 ohm resistor in parallel with a 6 ohm resistor. Okay, and so we can calculate it. We can say that 1 over R parallel is equal to 1 over R1 plus 1 over R2. 1 over R parallel is equal to 1 over 3 plus 1 over 6. We can then solve 1 over R parallel is equal to 2 over 6 plus 1 over 6. 1 over R parallel is equal to 3 over 6. R parallel is then equal to 6 over 3 or 2 ohms. Now let's take a look at question 6.3.2. It reads, calculate or determine the reading on voltmeter V1. So the equation that we can use to calculate voltage is V is equal to I times R. Now, what current are we going to use? What resistance are we going to use? That depends on where voltmeter V1 is connected. Voltmeter V1 is connected across this parallel branch. And we know that the resistance or the potential difference rather in parallel, or the voltage in parallel if you want, is going to be the same. So if I had to calculate the voltage for this orange branch, and if I calculated the voltage for the green branch, it's going to be the same because that's a property of resistors in parallel. Now, let's look at the information that we know for each branch. For this green branch, I know that the resistance is equal to 2 plus 1, which is 3. So 3 ohms. I know that the current, we worked it out already, is 2 amperes. We worked it out on the top. Now, if we look at this orange branch, all I know is that the resistance is equal to 6. I don't know the current value. And so if I want to work out the potential difference, I have a choice. I could either go with the green branch or the orange branch. Now, since we don't have enough information for the orange branch, we're going to use the green branch. So we substitute the values in. The current is 2, the resistance is 3, and so the voltage is 6 volts, right? So that's going to be the reading. So this is going to read 6 volts. Okay, now let's move on to the next question. The next question reads, calculate or determine the energy transferred to the 2 ohm resistor in 1.5 minutes. Now, where is our 2 ohm resistor? Our 2 ohm resistor is connected right here in this green branch, right? Now, there is an equation that we can use. Of course, we know that V is equal to W divided by Q. But we also know an equation for Q. Q is equal to I times T. And so what we can do now is we can simply replace this here. So V is equal to W divided by I times T. Since we want to solve for W, just take this whole bottom part and move it across. V times I times T is equal to W. And now we just substitute our values in. What is the voltage for the 2 ohm resistor? Right? So remember, we need to calculate that. V is equal to I times R. The current that's going through the 2 ohm resistor is 2 amperes. The resistance of the 2 ohm resistor is 2. So that's 4 volts. So V is 4 times I, the current is 2, times the time. How long are they talking about? 1.5 minutes, so 90 seconds. So 8 times 90 is 720. So 720 joules is the energy. All right, let's move on. Question 6.4. A wire of negligible resistance is connected from point X to point Y. Will the reading on A1 increase, decrease, or remain the same? Explain. So what they are essentially saying is they're connecting a wire here. Now, if they connect a wire there, what that means is that the 6 ohm resistor disappears. It goes away because no current is going to go through it. The current is only going to go through, the current is going to go here. So what's happening? We are removing, essentially, we are removing a resistor in parallel. So removing a resistor in parallel, means that we are increasing the total resistance. Now, if we increase the total resistance, remember that I, current, is inversely proportional to resistance. So if R increased, it means that the current I will decrease. So they want to know what's going to happen to A1. A1 is reading the total current. The total current will decrease. So A1 will decrease. And that's it. Thanks so much for watching. I'll see you in the next video.